This is Alyssa Poth recording Quideo number 1 for AP Statistics. So the first question gives us a table with profit as X and probability of Rotor Partners planning a major investment. And so profit X is uncertain, but a probabilistic estimate gives the following distribution. So part A tells us to find the profit mean and standard deviation of the profit. So first, to find the mean, you have to add all of the profit times the probability. So it would be like X times P1 plus X2 times P2 all the way through. So when you do that, you get an equation like this, and when you plug it all into your calculator, you get 3, but it's in millions of dollars, so it'd be $3 million. So to find the standard deviation, you first have to find the variance. So to do that, you take x1 minus the mu, which is 3, and you square that, and then you multiply it by its probability. So you do that all the way through for each probability and x value, and you get that the variance is $6.35 million. But then to find the standard deviation, you need to take this square root, which would be $2.5199 millions of dollars. And another way to set up that equation is right here in the textbook. So you have x1 minus the mu squared times p1 plus, and then you just repeat all the way through for all the values in the table. Part B says Rotor Partners owes its source of capital a fee of $200,000 plus 10% of profits X. So they give us this equation to represent that, and then it says from the investment find the mean and standard deviation of Y. So to do that, we would plug in, so we're trying to find the mean of Y. So in order to do that, we just plug in X as the mean of X, which we found in the first equation, or the first part of this problem. So when we plug in the mu, which we got is 3, we get the new the mu of Y to be $2.5 million. And then when we plug in to find the new standard deviation, we just do 0.9 times the standard deviation of X, and we don't use the 0.2 here, and that gives us $2.2679 million. The advanced question says an insurance company estimates that it should make an annual profit of $150 on each homeowner's policy written with a standard deviation of $6,000. Part A asks what reasons might contribute to such a large standard deviation. So we know that the standard deviation is $6,000 when the company estimates that its profit is $150 per each homeowner. So we can say that the standard deviation is so large because usually the company has to pay out very little, but when they have a large payment, it's usually like very large, so it contributes to the larger standard deviation. Part B says if it writes only 2 of these policies, what are the mean and standard deviations of the annual profit? So to do this, if it only writes out 2 policies and it's $150 per policy, we know that the average or the mean is going to be $300. And to find the standard deviation, we know that it's going to be $6,000 per standard deviation. Since they sell 2 policies and they're independent of each other, you have to add them together squared and then square root them to find that the standard deviation if you sell 2 policies is $8,485.28. Part C says if it writes 1,000 of these policies, what is the mean and standard deviation of annual profit? So just like we did before, it's the same thing except it's selling 10,000 policies instead of 2. So you would do 150 times 10,000 and you get $1,485,000. $500,000. And then to find the standard deviation, just the same thing again, since they're all independent of each other. You can do 6,000 squared times 1,000 and take the square root of that to find the standard deviation, and you'd get $600,000. Part D asks if the company is likely to be profitable and to explain. So I said that the more policies that the company sells, the more profitable it will be, because each sale is independent of the other, so you get that price and the larger standard deviation. The AP question gives us a scenario that was a study conducted to determine whether or not a newly developed hitch would be able to reduce the draft compared to a standard hitch. And so when a tractor pulls a plow through an agricultural field, the energy needed to pull that plow is called the draft. So they're measuring which hitch has the better draft. So to do this, they had 2 large plots of land, and they randomly determined which plot would be plowed using each different hitch. So part A asks us to identify what is the response variable of the study and what treatments they used and what are the experimental units. So a response variable is what is the effect of what you're changing. So in this case, you're changing the hitch, and so that would affect the draft amount. So in the response variable for this is the amount of draft. So then it asks us the treatment types, and the treatment types are the 2 things that you're changing to see which would better produce the amount of draft. So the treatment types are the standard hitch and the new hitch. And then the experimental units is what is being tested on, so the 2 plots of land will be the experimental units. So part B says, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in the study? Justify your answer. So it's basically asking if this study is random or not. And so we can say that the study is random because the 2 hitches were randomly assigned the 2 plots of land, and it was not preset. Part C says, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to a standard hitch, was replication used properly in the study? Justify your answer. So I said that replication was not properly used because each hitch had 1 plot of land, and that's it. So in order for it to be more accurate results and to be replicated, each type of hitch would have to be used on more than 1 plot of land. Part D says plot of land is a confounding variable in this experiment. Explain why. So I said that the plot of land is a confounding variable because soil quality could be a better explanation of the draft amount and the development of the plant rather than the hitch itself, so it would better explain the results. So that's Quideo number 3, Future Self. I hope you enjoy.